In this video, I'll be taking a look at common and special cause variation, and it's part of a series of videos around statistical process control. The specific learning objectives are going to be to define and provide some examples of what common and special cause variation is, to better understand the role that common and special cause variation have in the world of process improvement and this body of knowledge known as statistical process control. We'll also introduce you to some of the thought leaders associated with common and special cause variation, and we'll take a look at many of the statistical rules that define special cause variation. We'll take a look at some examples of those rules. I'm pulling some of the visuals that you see from the Lean Six Sigma data analysis workbook, but where I'd like to start with this topic is just by making a simple statement. We're probably all aware of it, but I'm just going to highlight it right now. Just calling it out, processes have variation. And part of the job of a process improvement specialist is to be able to see the inherent variation that all processes have. They all have it. Um, the question is the variation part of the common set of standard operating procedures, machinery, design, environmental conditions that are present when we work in this process? Or is the variation that we're seeing something unusual or special? And these charts, whether they're run charts or control charts that we're looking at on the screen, are supposed to help us as process improvement specialists see and understand and manage variation. All processes have it. Our job is to see it and determine, is there too much of it? Do we need to try to reduce it through some systematic root cause analysis using process improvement methodologies like DMAIC or lean thinking Kaizen events? Or is the amount of variation that we see tolerable and well within the needs and specification limits that our customers define? All processes have variation. Our job is to just understand it and reduce it if necessary. With that simple statement made, processes have variation. There are two main types of variation that we want to better understand and analyze: common cause variation and special cause variation. Simply stated, common cause variation is the variation that's the inherent wiggle or variation that we see that's part of the system. Special cause variation is that variation that we see or observe that has affected the system, but it is not part of the system all of the time. Some examples of common cause variation could include just the built-in design associated with the process and maybe the poor design that leads to a lot of variation. Or it could be the standard operating procedures or the rules or activities that we follow to perform this process. And it could be good standard operating procedures that create low variation or poor SOPs that create lots of variation. It could be the measurement system. It could be the environmental conditions like temperature and humidity, normal wear and tear. Those are all examples of what we would call common cause variation. They are controllable and manageable. Special cause variation, those are unique things, things that aren't part of the system, things that we really have little control over that we have to manage by exception. We have to be reactive over. Could be sickness that falls on a number of team members in the process. It could be machine malfunction or blow up that occurs, a computer crash, a power surge, hurricane that creates all sorts of service requests. It could be an unusual amount of traffic to the website because of some sort of unusual activity. Those are all examples of special cause variation. So now I'm taking a look at a visual display of variation in a system where on the x-axis I've got time or occurrence, and on the x-axis I've got the output of the process. This is drawing a chart of wait time per checkouts, and we can see variation occurring here, natural wiggle in the system. My question to you is, if we take a look at this really low point, or this really high point, or this point right around the mean, which one of those is output that is associated with common cause variation, the controllable, regular, built into the process variation, and which one of those occurrences is a special, unique, unusual special cause variation? Because those special cause variation activities, those are the ones that we're going to manage by exception. Those are the ones where we're going to swoop in and make corrective actions, add additional resources, equipment, dollars added. Which ones are common and which ones are special? Here's the thing. With a chart like this, a run chart, it's difficult to tell. I'm not really sure which of these values is normal assignable common cause variation and which one of these is special or unique cause. One thing that we could do that many people assume will help is to introduce the following. What if I introduced a spec limit to this chart? Remember, these upper and or lower specification limits come from the needs of our customer. The thought process is, well, anything that is outside of spec, here or even right here, these are all assumed to be then special cause variation. But I'd argue we still don't know. They are clearly data points that are falling outside of customer needs, and that's an issue. But just because data points fall outside of your specification limits does not mean that they are special cause. They are important things to consider, but they could be part of the natural wiggle or variation associated with the system. If these are painful points, the 4 red circled areas, but maybe they're not special cause variation, due to very unusual phenomena, we as an organization are probably interested in trying to reduce this variation, but to reduce variation associated with a process, we want to do systematic scientific method approach process improvement, whether that process improvement is to make or Kaizen, lean thinking principles, PDCA, any of a dozen different data-driven scientific method approaches could be used, but it has to be systematic. It can't be reduced by just swooping down as a manager and attacking these painful incidents. Matter of fact, 2 thought leaders developed some experiments and some tools to show that if we as managers or process improvement specialists swoop down and make corrective actions to these painful incidents, we in essence are adding to the amount of special cause that's occurring in the process. We actually increase the total amount of variation in the system because, see, these corrective actions are arbitrary. So how do we determine if something is special cause? Well, let me introduce a thought leader that helped to determine this. His name, Shewhart. Let's take a look at him next. W.A. Shewhart, many people consider to be the father of statistical process control and the person associated with thinking about common and special cause variation in process-driven environments. Photo of him right here. And he was around a long time ago. It was the early 1900s when he first developed what we now call the control chart. Shewhart is associated with creating some statistical rules around defining what is special and what is common cause. He identified a number of statistical rules that he defined: special cause, unique cause, assignable cause variation. And let's take a look at what those rules are next. One of the rules that Shewhart identified as special cause is related to our empirical rule study. I've drawn normal distribution, and we know from earlier videos that outside of the plus or minus 3 standard deviations, data should only occur there 3 out of 1,000 times. He said, you know what? That's pretty unique. We're going to say anytime we see data that's outside of 3 standard deviations, we're going to assign that as special cause. We'll make that one of the rules. Why did he not choose 4 standard deviations or 2 standard deviations? Because 3 seemed good enough. 3 out of 1,000 was good enough. That was pretty unique. But there are other statistical phenomena, like a certain number of data points that fall above 2 standard deviations or below, a certain number of data points that fall above or below 1 standard deviation. Sawtoothing, where you're going up and down and up and down and up and down. A number of different unusual statistical phenomena with data. He assigned each he created rules for each of those phenomena and created what we now call well, sometimes it's called the Western Electric rule set, and other times it's called the Shewhart rule set. Sometimes it's called the Western Electric plus Nelson rule additions. Let's take a look at what these common statistical phenomena associated with special cause variation are. So here's what I've got now. I've got our drawing, but then I've also included process data in this example above, where right across this line right here, here's our mean or the center line, process performance data over time. Anytime I've also included the +1, 2, and 3 standard deviation lines. And anytime data fell above or above 3 standard deviations, we'd call that special cause. Anytime 2 out of 3 data points in a row were above 2 or plus or minus 2 standard deviations, like here or here, those were statistically unusual. We call that special cause. Anytime 4 out of 5 data points in a row were above 1 or below 1 standard deviation, like right here, that was assignable special cause. Anytime you saw 8 data points in a row above or below the center line or the mean, that was unusual. Each of these would be assigned special cause variation. And if we could draw a chart that showed our process data and highlight when we were above or below the 3 standard deviation line, or any of these other characteristics that were highlighted, we'd highlight it in red and we would say those are situations in which managers should go down and treat it as unique special cause variation. If it wasn't above or below 3 standard deviations, but it was outside of spec, that was part of the common cause variation associated with the process. It might be painful, but the only way we're going to get rid of it is not by swooping down and treating it as special cause. Instead, we need to be systematic, measure that variation, determine root causes, and build solutions in future state that attack those root causes associated with variation. Don't treat common cause variation as special cause variation. Below, I include some of the Nelson rules, just for an extension to the Shewhart rule set. The biggest one being if you saw a trend of 6 or more data points in either ascending or descending order, that was statistically unusual. And these rules, together with the time series chart known as a run chart, all bundled together create what is known as a control chart. And in follow-up videos, we'll take a look at how we read and interpret control charts, how we build them, and how we use QI macros for the analysis. We'll take a look at those next.